So now let's venture towards the concepts or the idea about function pointers. These, remember, are the kind of the second category of, so when we talked about roughly the types of pointers, and again, the spec doesn't specify types of pointers or anything like that. It's just something that I follow to understand or categorize pointers. So one type of pointers were those that pointed to data types, right? Data types based, let's say. And the other we said were function pointers and kind of, also these are sometimes called callback callbacks, right? Depending on how they're used, they're also called callbacks. So now the thing is, and the third type we said were like the void pointer, right? And we are kind of done considering these. We are now going to focus on the function pointers. Well, the function pointers, the key thing about them, that if I were to ask you to remember anything about them at all, then that would be this, that the function pointers are some sort of pointers that point to memory region, right? That point to memory region or the memory location where some code is placed, right? So this content is code. And code are what essentially? So, we talked about memory going from top to bottom, lower address, higher address, uh, bytes. Um, so on each of this byte are numbers that the CPU interprets as a code, right? So anytime CPU fetches content from here, it will treat that as a code, and the code can be, some combination of zeros and ones that maybe convey the operation, let's say add, two numbers together, or move data from one place to another, something, you know, but it is code, and code is something that the CPU instruction by instruction follows and accomplishes a task essentially, right? And so function pointer then, let me just write it here. Function pointers, point to memory and the content is assumed to be code or instruction. And remember that these instructions are nothing but binary encoding or something called machine code, right? And machine code is essentially the bit pattern that the CPU would infer to be an instruction that it can go ahead and execute, right? So it's as if there is a recipe here that the CPU will execute. And mind you, uh, if you have a pointer, a function pointer, and we haven't seen as to how to define them yet, which we'll look at, but if you have a function pointer and it points to random memory location and you kind of dereference it, recall dereference is same as, hey, go ahead and get me the contents, right? So when we try and dereference it, so to speak, then what happens is the contents at that memory location are treated like instructions, right? And so it is assume that a function pointer, wherever it is pointing, whatever number it is storing in terms of the memory address, it is assumed that the memory at that address has instructions, right? And there are certain special things about the function pointer in terms of dereferencing it. But remember, the thing that I want you to take away is a function pointer is nothing but a pointer, so a variable that stores an address, and that address happens to be uh, of memory location where you have code. That's the key. In case of the data pointers, recall that the memory location was assumed to have data, and that too data of the data type that the pointer was pointing to. Right? If we said int star p, it was a 0 or pi, let's say. So pi, we said, would point to memory location, and anytime we dereferenced it, anytime we did this outside of the declaration or definition line, we said that this is dereference, and dereference means, hey, go and hug 4 bytes, because an int is 4 bytes. So that was encoded in the data type. And we said that this would be interpreted as data. Again, in case of function pointers, dereferencing means that that location has an instruction. And that has interesting connotations in terms of the memory model that we were following. So let me go ahead and clear this, and then let's try and visualize what it means to be a function pointer, right? So again, recall a beautiful, model of memory where we said that, we had a byte long entry, or most granular access we can have in the memory is that of a byte. And we said it goes like from lower to higher, higher number, and increases top down. And then we said, there are buses. Buses are nothing but wire again, a bunch of wires actually. And we said that, one of the buses were bidirectional, and the other bus was kind of unidirectional or one way. And then we mentioned that this is like the data buses, and this we called as instruction buses, right? And then this was like the address bus, this was the instruction bus. All right. Okay, also I made a mistake here. So, right. So usually what happens is that the instruction just comes out of the memory. Oh, okay, let me get this back. Yeah, instruction comes out of the memory. Uh, right. This we said was address bus again, but for the for the data, and this we said was data bus, right? All right. So now recall that the data pointers were floated or were sent out as the value of the data address bus. Right? That's how we reached out to the memory, and then the memory sent the data essentially from here, or went ahead and updated the value in the memory based on what the address was. In case of function pointers, and this is key in terms of being able to imagine what a function pointer does, which is the function pointer or callback functions or callbacks, so to speak, function pointers, right? The pointer's value or that address is actually put onto the instruction address bus. And as you can imagine, what comes out, from here towards the CPU, and CPU is on this side. CPU is the one, issuing the addresses. So the CPU issues the address on the instruction bus. As a result, whatever that address was, the data coming from that is put onto the instruction bus, right? So the address is on the instruction address bus, and whatever the content is sent back on the instruction bus or instruction data bus, so to speak. And the CPU, the internal machinery of the CPU, is treating whatever the content came as an instruction, right? And if you happen to know about something called program counter, so this is like a register within the CPU that kind of, on all CPUs more or less, that kind of keeps track of which instruction it is fetching. So when we dereference a function pointer, when we try to get the contents of a function pointer, what happens is the value of program counter changes to whatever the function pointer was, having. And then what happens essentially is the CPU takes the value of PC, puts it onto the instruction address bus, which always happens, by the way. Program counter value is the one that it puts on the instruction address bus always. And then the return is, or whatever comes back, is an instruction. It's treated like an instruction. And that instruction is what the CPU will execute. Now, let me again re-emphasize this, that in case of dereferencing a function pointer, the program counter value is changed to the value that the function pointer was holding, the address that function pointer was holding. And because of that, right, the instruction that the program counter was going to fetch changes. The location from which it was going to, you know, fetch the instruction changes because now it is floating the function uh, pointer's content. Let me give you an example. Let's say the function pointer is holding the address hex 4, right, for example, and our program counter was pointing to the location, let's say hex 1234. What it means is the CPU was fetching instructions from the location 1234, right? And the next thing in our program in the instructions was, hey, dereference the function pointer. What then that dereferencing means is, hey, load the program counter not with this. One instruction is assumed to be 4 bytes here, right? That's how it is for most CPUs. So hence next instruction would have been here. But what we are saying is, hey, no, don't upgrade the program counter automatically to this. Instead, put or point the program counter to hex 4. So the next time when the CPU is wanting to fetch an instruction, it will put the value of hex 4 on the instruction bus. Right? And that is how a function pointer dereferencing works. Now, again, if this sounded too much cryptic, don't worry about it. The key insight is that program counter is manipulated somehow, and function pointer dereferencing fetches instruction, and that instruction, the way we get it is by interacting on the instruction buses.